Howdy y'all, it's Jay from Geolojay. I was sitting here cleaning up my kitchen here a little bit this afternoon on Sunday, the 23rd, and I had a unique idea to try to demonstrate something for those of you that are into groundwater flow modeling, particularly young hydrogeologists that are interested in groundwater flow modeling, and you know, the educators, the teachers and professors alike. You know, maybe you can use this to demonstrate this, what I'm going to talk about here in a moment, which is called the head change criterion, which is a term used in ModFlow, the United States Geological Survey's modular finite difference groundwater flow model software. For those of you who have no idea what I'm talking about, just enjoy the ride on this. What I'm going to be talking about in terms of hydrogeology, which is the study of earth and water in earth materials, or more accurately, oftentimes we refer to groundwater, okay, but hydrogeology, a little more accurately, is the study of the occurrence, the movement, and the quality of groundwater in earth materials, okay. Groundwater flow modeling is a slightly later, a little more advanced topic in hydrogeology. You probably get it in most intro college courses, university courses, that sort of thing. Basically, we build groundwater flow models. There are two components. There's a physical structure that we program into a software code using a computer, and then there's a hydraulic framework that we build into it, and then we can basically try to simulate, after we calibrate the model to known observed conditions that we see in the field, taking measurements from wells and other hydraulic information. We can calibrate the flow model, and then we can use it for predictive analyses once we're good on the calibration and comfortable with that. But let's talk about, to the hydrogeo folks, the head change criteria. If you've used ModFlow, you know that there's that parameter you have to enter for your head change criterion. Okay, and what that really means, and I'm going to keep this simple. If you're just trying to visualize it somehow, this demonstration should help. And the head change criteria is the number that when you start the simulation and you are doing your iterations of all your mathematical matrices, all right, between iterations, between model simulations, okay, at every cell in your ModFlow model, at the end of an iteration, the software is going to look and it's going to compare that, the hydraulic head in each cell to the hydraulic head in each cell in the prior iteration, okay? And if you exceed that hydraulic head change criterion, then the model is going to say, the software is going to say, this model is not converged yet. I'm going to do another iteration, and I'm going to start using the last iteration hydraulic heads as the starting point. And it's going to keep going through that process until you do not exceed that head change criterion, at which point your model will not, it's going to converge and you'll get a solution, okay? And then you have to go and you have to compare, you're familiar with that graph of the, computed hydraulic heads versus the observed hydraulic heads, and you draw the line and you post all those dots on the graph. The closer those dots fall to that line on that graph, the more confidence you have that you have a good solution for your model. And then the second thing you have to check is your water budget, okay? You have to account for all the water that goes into the physical framework of your model, and you have to see where it all goes, all right? And that's where we get to the steady state part. Steady state is, again, in simple terms, the flow rate in has to equal the flow rate out when you do all your budgeting and do all your simple additions and subtractions in the end. All right, so let's use this ice cube tray, which is my idea here while I was cleaning up. This ice cube tray we can use as the kind of the physical framework of our mod flow model, our groundwater flow model, okay? And these individual cells in the ice cube tray can be your individual cells in your groundwater flow model, okay? And what we want to do is we want to show that when the model starts running, the heads are going to change as the model fills up with water and it starts to move around based on all the properties that you've assigned to the aquifer. You know, hopefully they come from field measurements and it's not a total arm wave. But at some point, the heads are going to stop moving. Okay, they're going to stop rising or falling. Okay, and that's where that head change criterion comes in. So what I'm going to do is I'm going to turn this water on. Okay. And I'm going to allow this model to fill with water. And what I'm going to try to do is I'm going to try to orient this and hold it real steady so that the water goes into this uppermost cell, and I'm going to hold it at an angle. This first cell is going to fill up with water and then sequentially fill these other cells until hopefully it spills out this bottom line. I haven't even done a dry run on this, but it should work on paper. Anyways, at some point you're going to see that the water coming in to this whole thing is going to equal the water that spills out here down into the sink and then down the drain. Okay, at that point we've reached steady state. Okay, Q in equals Q out. The flow rate in equals the flow rate out. Evaporation is going to be pretty much very small of this. It's going to be insignificant. Okay, and we don't have any wells in here taking water out. We don't have any streams going by or anything like that. So it's very, very simplistic. Okay, and when we get to that Q in equals Q out and that steady state flow, by definition, the head is not going to change. The hydraulic head is not going to change at all. It's going to be equal to 0. At cell XYZ, or in mod flow IJK, at cell XY, at location XYZ, the change in head through time equals 0. Okay, that's what it all means when you get down to that big giant equation that you can, you know, hold things constant and simplify it down to that. All right. So the change in X, Y, and Z, the change in head with respect to X, Y, and Z through time is going to equal 0. So all these heads are going to remain the same. But the key thing that I want you to take away is when this first starts, if you watch these cells, and I'm going to post this on the blog in a minute, okay, when I'm done here, you're going to see the water levels changing rapidly at the very beginning of this whole demonstration. And then they're not going to change at all once we've hit steady state groundwater flow in this case. Alright, so I'm going to turn this water on. I'm going to let it go. Hopefully it's not too loud on that camera. But I have to get this going because it's so cold outside that the pipes are a little, they need to make sure that water is flowing through them so this flow rate doesn't change too much. It's very, very cold for the southeastern United States right now. It was about 22 degrees last night. But let's just get this going. It might be a little too much. Let's get this going here like this. And let's start the demonstration. Again, I'm going to try to hold this as steady as possible so you can see. So here we go. You can see all the cells filling up. I got some loss on the side there, but I'll adjust. And you can see all those heads change until, boom. Now particularly note this cell down here was changing a little bit, but they're all filled up. Let's do this again with a little less flow rate and a little bit more of an angle so you can see where the water levels are. Let's try this again. See all that water, all those water levels changing? And at some point, in this case, we even have some dry cells, but we're not going to get into that in this discussion, okay? We have some cells that did not fill, okay, which is common in a mod flow model, okay? It happens. It's just the way it is. So hopefully you can see this through this demonstration. A better visualization of the head change criterion, and I'd like to thank you very much. If you have any questions, just post them as a comment, and thanks for stopping by. Have a nice day. Appreciate it.